Okay. Today I'm going to work on some more Rust, and in particular, I've seen a couple of people with live coding recently using pattern languages similar to the mini notation that TidalCycles has, which is an excellent live coding language if you're not familiar with it, written in Haskell. And I love TidalCycles. It's difficult to embed for a bunch of reasons. Otherwise, I might actually just be using it. So I would love to have something like that. Let me talk about what I mean a little bit. That's not what I wanted. Also not what I wanted. What's this thing I made? Okay, so what this looks like is right now I have the ability to produce these sequences, and so they would look something like you have a clock, something like that, so 120 BPM, and then you can make a sequence. So sequence. I've got a little bit of syntax for this because they're, for reasons which I may fix in the future, they're qualitatively different from a regular node constructor in the live coding stuff. It looks like this, and so that is sort of like listy notation, and then I give it a clock, and then inside the list, I can have values. So, 1, 2, 3, 0, whatever. And what this does is every time the clock triggers, it switches which of these values it's outputting its output port. So and then it loops at the end. So it's a real basic sequence like you might have on any just simple sequencer. And so this exists right now, and it's useful. But there's things I'd like to be able to do with this that I can't currently. So an example of something that these kinds of pattern notation languages often have, and I actually can't remember the syntax of TidalCycles one, although I think it's something like this. It's something like this. So here's an example of the thing I might do is what this would say. This is no longer legal syntax in my language, but it's what I'm going to try and implement. What this would say is, every beat of the clock, go 1, 2, and then this is a tuplet, basically. So I go in this beat, so in the third beat, I'm going to go 3, 4, and then on the fourth beat, 0. And that lets you nest, potentially arbitrarily deep. So I can go, and so you can get complex patterns that way. I know that TidalCycles has some other variations in theirs, which I also like and will probably try and support. So things like, I think this was the syntax that they used, or something like that, which says, every beat go 1, 2, and then on the first loop, 3, 0, and then you repeat. You go 1, 2, and now on the second loop, 4, 0. So it gives you sort of like call and response pattern type things. And that I found useful in Tidal, and I would like to have it as well. And you can imagine other variations of that kind of thing you do there. One of the... So anyway, so this is, I think, basically the syntax I'm going to have. So I'm going to start with this version. It's going to look like that. And then I'll try and leave it open to support other interesting operations or sub-pattern stuff. One of the things here is in order to do this, packing more densely into the beat than once per beat, I need to be able to multiply this clock. I'm not entirely sure what the right way of doing that is. For the sake of simplicity, what I'm probably going to start with, and this may actually just be the right solution, is to do something like, I give it a clock that's actually faster, like that, and then I say divide that clock by 4. So that means that, 1, 2, 3, 4, bam, 1, 2, 3, 4, bam. And now I'm in a world where I'm dividing not by 4, but by 8, or by 2. And I go 1, 2, bam, 1, 2, bam. And now I'm back in a world where I'm dividing by 4, and 1, 2, 3, 4, bam, right? The disadvantage of doing it that way rather than having like an actual clock multiplier is I can only nest as deep as I have headspace by this divider. But clock division is just simpler to do than multiplication. I actually think I have some code for clock multiplication somewhere in the system, but I think I want to do the division version just because it's simpler. And that has sort of the interesting, maybe useful property that I could then modulate this clock division. I don't know that that's independently of the actual clock speed. I don't know if that's actually useful, but it's a widget that would let me have. Okay, so that's what I'm trying to build, and that is probably the last time we'll actually look at the live coding line today, because everything else is going to be here. So this is the Rust trying to find my nodes. And I already have a sequence in here, which doesn't have this concept of like patterny stuff, sub-pattern stuff. So I think I'm just going to ignore that and basically start over. And like I usually do, I'm going to start by copying the code for the last thing I wrote, which is that quantizer. And it's going to be we're going to call this, who knows, pattern sequence. Sequencer, seems reasonable. Okay. And now it's going to have not values like the quantizer has, but a sequence. Sequence is going to be a list of not floats, but sub-patterns, sub-sequences. Let's say that. And so this is going to be the same thing. This stuff is just totally irrelevant. And we'll come back and fill that in. Okay, cool. So now I need to think about what this subsequence thing is, because it doesn't exist yet. So it's going to be some sort of a num that represents sort of all the different ways these subsequences could be nested. Then the basic thing is we have just an item, call it that, item. And an item is just going to be a floating point. So this is my basic sequence where I go like every beat, 1, 2, 3, 4, 1, 2, 3, 4. And those, the 1, the 2, the 3, and the 4 are just going to be items. So it's just, this is the floating point value that we should output, for this item. And then I had that thing I wanted to support of subsequences, which I'm kind of tempted to call tuplets, although I think the music theory people will yell at me that that's not really what it is. But I'm going to do it anyway, because none of them are watching, so it hardly matters. And a tuplet is itself a vec of subsequences. So it could be nested. I could have tuplets inside of tuplets. Or in the simple case, a tuplet is just a list of items, right? And then I can expand this enumeration to support other things like that, alternation, that I talked about a second ago, or things where I might have a list of choices to choose from randomly every time it cycles through, which is another thing that these often do, which would be super interesting. So for building cool patterns. Okay, cool. So now I need to know how to move through my sequence. I need an index, which is a little bit complicated, because since these subsequences are recursive potentially, my index is not just the index into the outer sequence. It has to be recursive as well. So I think the way I do that is I make an index into the outer sequence, which is just a usize, and then my tuplet actually carries its own index, which is also a usize. And that gives me that recursion. I think that'll work. Okay, and then to build my triggering mechanism, I need to have a Schmidt trigger, I think is what that's called, where you trigger when the signal rises above a threshold and sort of unlatch when it falls below the threshold. I think that's called a Schmidt trigger. Anyway, whatever it's called, that's what I've been using elsewhere. So I have a bool that represents whether or not I'm in the triggered state or the untriggered state. So if I'm when I rise above my triggering threshold, I enter the triggered state and do whatever happens when the trigger fires, move the index forward. And then I stay in the triggered state and I don't re-trigger until I fall below the threshold, at which point nothing happens except that I unset the triggered state. And then the next time I rise above the threshold, I'm eligible to trigger again. And so that works pretty good for this kind of stuff. But I also need this this clock divisor concept, which means that I need not just my trigger, but I also actually need to track a clock as well, which I don't normally have to do for this kind of thing, but something like that. Okay, and these things can all be just set to defaults. I can do 0, trigger starts as false, and my clock also starts at 0. Okay, so I think that gets me set up for what I need to do. That. Now, okay, so now let's think about my actual node implementation. So I have actually 2 input ports, one of which is the clock, and the other of which is the clock divisor. So in my other example, that was tempo and 4, right, would be these 2 values. Probably the clock divisor doesn't actually get modulated very much. I don't know, we'll see. It's useful to have anyway. Okay, so let's just start off by unpacking those. Also, I haven't talked about this very much in previous videos, but this is this particular node is running at control rate, roughly. My control rate, signal rate stuff in this code is a little bit sloppy, but basically this is control rate. So if I were running this at signal rate, these would be usize block, or not usize, SIMD blocks like that, but they're not. So this is a control rate, which means this actually, under most circumstances, will only tick every 8 samples, which is that 8 divisor is my control rate to signal rate divisor. I think often for control rate you go much more than 8. especially for particularly slow moving stuff. But it just 8 is convenient, so that's what I have. I may actually get rid of the concept of a control rate entirely. There's a big refactoring of this stuff looming. And one of the things that might happen is that I just do everything at signal rate. I don't know. We'll see. Okay, so first I'm going to unpack this. So I'll just destructure the value, which looks like clock signal and clock divider, I guess. Okay. And then I need to, let's see, a little uncertain how to do this. So I know in my outer index, so basically I need to know what kind of subsequence my index is currently pointed at. I think this is right. So I've got to unpack that. So I'm going to match self dot sequence AX. Okay. And that's going to be a subsequence item, some value, and that's going to be my simple case. And then I'm going to have a more complex case where it's a tuplet. And that's going to have a subsequence and a sub-index. That's my more complex case. Okay. And yeah, okay. So in the case where I'm currently pointing at an item, I know that the result I'm going to omit is just the value of that item, right? So I know that my output is going to be this. So that's very simple. The thing that's more complicated is I need to figure out, I need to figure out, is it time to advance my index? So what I need to do is, I guess I advance the clock first, because the underlying clock doesn't care about the clock divider. Okay, I think this is right. So here's where I do my Schmidt trigger stuff. So if I am currently triggered, that means I have risen above the threshold and not dropped back down below it. Then what happens? Nothing happens. I don't advance the clock at all. Yeah. So actually, the case I'm interested in is if I'm not triggered. I'm not triggered, and clock signal is greater than the threshold I've been using is 0.5. That's pretty arbitrary, but so far it's worked. Okay, so now the first thing I do is I move myself into the triggered state. And then, actually, what is this? Because then I can go else. Now I know that I'm in the place where I want to unlatch the trigger, which don't think I'm going to do anything in the unlatching case, so I can just, always set that value and it's fine. Okay, so now I know that I was above my threshold and I also wasn't triggered. So now I need to trigger, and in addition to that, I need to advance my clock, my internal clock. So self.clock. And obviously for very long running things, this will eventually overflow. But even at like a high BPM, it has to run for a really long time, so I'm just not going to worry about it. There are a lot of clock increments in the U32. Okay, so now I have my clock that is updated for the current sample. And so now I can look at that here. So I know that if the clock modded by the divisor, which is a floating point. So I need to floor it, I guess. Also, this is unsigned, so just need to make sure that that's above 0. So if it's below 0, what is something mod 0? Is it always 0? Then it'll just move forward on every tick. I don't know, whatever. It's a garbage case anyway. That may be a bug waiting to happen. And if that equals 0, then it is time to move the index forward. And we just do that. So self.ex equals self.ex modded by self.sequence.swim. So we move that and then loop back to the beginning if we fall off the end. Okay, so that's the really simple case. And I said I wasn't going to go back to live coding, but let's just no, because I have to write a parser. So no, I was going to say let's test it, but that's a little tricky to do, so let's not test it. So now in the subsequence, I have to descend into my potentially recursive sequence. And how do I do that? So basically, each subsequence tuplet is going to have not only its own index, but also its own clock. Does that make sense? No, I can still use the global, or the parent's clock. I think that's right. Okay. So what I need to do is I need to figure out based on and so since the tuplets might not evenly divide the beat, might not evenly divide the clock divisor. So if I have a tuplet that's like 3 items long, then I need to divide the clock unevenly. Not unevenly, onto integers. So what does that mean? Means that my clock divisor is potentially floating point in this case. So my effective clock divisor floating point divided by sub does that make sense? So if my outer clock divisor is 4, and then I have a tuple with 2 items in it, I need to move forward every 2 beats. So that works. And if it has 3, I need to move forward every 3/4 of a beat. Or every beat and a quarter. Or beat and a third, I mean. And yeah, and that also works. Okay, I think this is what I want. Okay, and so then the logic is very similar. It is very similar, but it is recursive. So I need to say, what is the value of this subsequence now? That's not what I want. Subsequence dot current. And in order to get the current value, I'm going to need to know what the clock is. So that is clock. Also, what the effective clock divisor is. Divider. And then that current method is going to have to take care of moving the subsequences index forward. And then I need to know somehow if it is time to move the outer index forward, which is, with the simplest way to do that, we'll just have, I'm just going to return a tuple. It says do tick if do tick, then self.index equals self.index. And then the thing we return is whatever that value is. Okay. So now, as is suddenly obvious to me and possibly also to you, this code doesn't actually belong here. This code belongs inside the subsequence, inside this current, inside this current method implementation, which I have not yet written. So, why put those parentheses there? Don't need them. Which means that this outer thing is, which means this doesn't actually need a sequence at all, right? Because this is literally recursive. So the sequence is just a subsequence, which may be a tuplet, and it doesn't need to track a clock or an index. Okay. In which case, this is, if we can just take ownership, that's fine. Like this. Don't care. No, I'm sorry, use this, I still need a master clock. Okay, cool. But this doesn't track the index anymore. All it does is it goes value. Yeah. All it does is go. Right. Right, yeah. So the reason I'm pausing is because when I do this, the current call, so I go like this, self.sequence.current self.clock and clock divider would be floating points. This is returning two values, one of which is the actual current value of that thing, and the other one is an indicator that the parent should take its index. But the parent has no index in this case. And I think it's going to work if I just ignore that. I think that's fine. Okay, cool. So that method actually becomes very simple. And then this stuff, the complex bit, it actually goes into an implementation on this. Current. It needs a mutable reference to itself. It takes a clock and a clock divider, which is floating point, and it's going to be returning a value and an indicator of whether or not the parent should. And this is going to be most of the code. So, what do we do now? So, when this subsequence is just an item, it has no index. What that means is that instead of updating the index, I'm going to go do tick equals this, and it is true in this case. Otherwise, it's false, and we return it here along with the value. And so self.clock, I'm looking at clock. Okay. I think that's good. Oh. Did I? I did. I converted this floating point because I'm thinking of it as an integer, but it's actually coming in as floating point because it comes in as a modulatable input, so it's already float. Okay. So I think that's what we want there. So now tuplet is also going to be pretty similar. It's got a subsequence. Subsequence, which doesn't have a current because it's actually a, so don't need to wrap this in a value. Don't need to do that lookup. Reference that. Thank you for compiler for helping me write your code. Okay, now, so let's just clean up this. So this is do this clock divider thingy, which is cool. That's what we want. This is wrong. So what I need to do is I need to go self.subsequence sub x current. Here's where I actually do this, and that gets the clock and the current clock divider. Cool. And then that gives me a value. Okay, and so this place I do actually have an index. So I need to take my index, and that's going to look like that, not like that, it'll look like this. So now I've potentially fallen off the end of my sequence. And that's useful because shadow this. So I know that the outer thing only needs to tick if the inner thing ticked. Otherwise, nothing changed. It doesn't matter. If the inner thing ticked, I'm going to tick the parent, if this rolled off the end of the sequence. So if x is greater than or equal to length, then I need to, since I'm moving by 1, it will always be equal to, in which case I just go like that. And just move back to the beginning. But I go true, because now I know the internal sequence looped, which means the outer sequence needs to actually move its index forward. If the internal sequence didn't loop, then we're still working on that internal sequence. We don't need to move the outer index. That. Okay. That might actually be all I need. Let's just read through that quickly. So I have a pattern sequencer. It's got a sequence, which is a recursive thingy of these subsequences. That's fine. I have my Schmidt trigger stuff. I have a global clock. Or not global, but a parent clock. And I set this up by taking in a subsequence. That's fine. That's fine. Okay. I take a clock signal, trigger signal, and a divider, and I output a value. Fine. That's good. I'm over my threshold and not already triggered. I trigger, I move my clock. Otherwise, I'm below the threshold and I untrigger. Okay, fine. And then I just return the value of whatever the current value for the top level subsequence is, which drops me down into this. And that's got two cases where the current thing is just an item, in which case I check to see if my clock has moved past the sort of the beat or subbeat that this item represents. I think that's fine. And then that. If I have it, I increment the outer clock. If I haven't, I don't. Whatever it is, I just return my value. Here's the case where I have an actual list of things. Okay, so here's I think a problem. So in the case where I have a single list of items, this is like my simple case, right? I just have a list of like 1, 2, 3, 4, and I want to move forward every fourth trigger. So that's my divide. That's my starting divider. That's not what this does. What this does is this moves forward every 4 divided by 4, because my sequence is 4 long, triggers. So every trigger. So that's not actually what I want. So to fix that, what do I do? I think I have to adjust the divider that I stick in at the top to make this make sense. It feels a little bit like a kludge, but I think it's right, so let's just do it. So I'm going to do that by saying this can give me a length. And so I'm going to match self. Self is a subsequence item. I don't actually care what it contains in this case. So if self is an item, my length is 1. If self is a tuplet, my length is the length of the subsequence. I think that makes sense. Okay, and so then down here, when I enter the top of this or this top of the thing, I don't give it the clock divider. I give it the clock divider times whatever the length of the topmost, the outermost subsequence is. So if there's a single item, that will be 1 times 4. So my global divider is 4, which means that this thing gets, in this case, I get a clock divider. It is 4. I tick every 4th thing, which doesn't actually matter because there's only one value, so it just stays, but that's fine. Here, if I have a list of, say, 3 items in my subsequence and my global clock is 4, then I'm going to adjust that to be 12, and then here undo that adjustment to bring it back down to 4, which is what I want. Okay, I think that makes sense. Once I get to the point where I can actually test this, we'll see if it sounds right, but I think that's correct. And then, what do I know? So if the inner thing ticked, then I need to update my index, which I do by that. If my index falls off the end, I know that I need to roll, so I roll, and I know that my parent needs to tick, so I tell it that. Otherwise, the parent doesn't need to tick, I tell it that. And then if I didn't tick at all, the parent definitely doesn't need to tick, so I tell it that. Okay. So I think that's, I don't know, right-ish, if not actually correct. And just to see if it compiles. Okay, cool. So it does compile. And that is, that's that. So that doesn't give us the parsing for these patterns in the live coding language. It just gives us the sort of the underlying implementation. So I'm going to stop, and then next time I'm going to pick up and I'm going to write the parser.